Hello everyone and welcome. Today I would like to talk about flatten binary tree to linked list. There are two requirements. First, the linked list should use the same tree node class, where the right child pointer points to the next node in the list, and the left child pointer is always null. Second, the linked list should be in the same order as the preorder traversal of the binary tree. An example is the following. So given these two requirements, it is possible to use a recursion-based depth-first search inner function to implement this solution. This solution is actually a modified preorder traversal, as you can see in these two lines of code. And this solution will give us a new tree. And this new tree will follow this preorder traversal as required. However, this solution has a space complexity of On. You can see the recursion stack uses On space complexity, and the new tree also uses another On space complexity. So it's about O2N. The question now here is, can you flatten the tree in place with O1 extra space? So we want to challenge ourselves. Can we rewire the binary tree into linked list in place? Do not use auxiliary data structure. Now, let's look at how we can rewire the binary tree to a tree with preorder traversal. We'll be looking at this three steps closely. To have an order like this 1, 2, 3, first we want to know if the left node exists or not. Because if it doesn't, then we move on. If it exists, first we want to point the right child of the left node to the right node, as in here. Next, we want to have the right pointer point to this original left child. So now it becomes the right child, as in here. Finally, we know that the left pointer is still pointed to this new right child. So we'll fix it by having the left pointer to be none, as in here. Now that all the nodes have been rewired, we'll move on to the next right child and repeat the whole process over again. After we have studied the previous simple case, now let's move on to a more complicated case with a height equal to 2. The only difference in the code is this dot right, and the idea is to have the right child of the original left's rightmost leaf point to the original right node. So we handle one left node one at a time, move it to the right node, and link its rightmost leaf right to the original right node. Finally, we can expand this line of code to find the rightmost leaf of the left child node in general. And this will be our general solution to this question, where we handle one left node at a time, move it to the right node, and link its rightmost leaf right to the original right node. Now that we have covered the basis, let's write the code. So first of all, we will have a variable called node pointing to the root. And then if the left child exists, the simple solution says we'll have a right child of this left node point to the right child and have the right child point to the left node and have the left child point to none, and then move on to the next right child. And here for general solution, we'll have a variable is about rightmost leaf of left child is this variable, and then I have this variable right point to the node right. And then we're going to find the rightmost leaf. If the right exists, then we should point to the right. Okay. And we're going to do this recursively after this node equal to node dot right. So while node, and we'll continue to do this. Okay. Now we can test the code to see how it works. So we submit and pending judgment done. It passed the requirement. It's very good. Finally, we'll analyze the code for complexity. So the code has a time complexity of O(n) since we use a while loop to traverse through each node once. And then it has a space complexity, importantly, O(1) extra space. Since we use only extra space like node variable, rightmost leaf of that child variable as constant variable as extra space, so it's O(1) extra space. And we didn't use any stack for recursion or iteration. Okay, so that's all for this video. Hope you find this video to be useful. Please subscribe for more videos. Hope to see you next time, and goodbye.